So in this video we want to show you a full installation and commissioning guide of a Gen24 Plus inverter together with a BYD battery and a Fronius smart meter at the feeding point. Now before we start with a guide of installation and commissioning, let's talk a little bit about some technical specs. So with the Gen24 inverter we have a very high IP rating of 65. So it is possible to install it indoors and outdoors with no problem. However, we must make sure that there is no direct sunlight on the inverter. So a shaded scenario is necessary. So we also see that there is an active cooling in the Gen24 built in. So we have a very centrally positioned fan sucking in the cold air from the front, and the hot air is distributed around the inverter. So make sure this is not getting covered. Now about the BYD battery, it is as well a very high IP rating with 55 outdoor and indoor installation possible, and also a very broad temperature range where you can install it. So from -10 to +50 degrees. However, please make sure that our recommendation would be to search for a room to install only in a room where you have +10 to +20 degrees ambient temperature around the whole year. Because if it's getting too cold, you're getting not the full power out of the battery. Also, in the technical details of the battery, in the installation manual, you can read that there is a distance, a limit between inverter and battery of 20 meters that must not be exceeded. Then about the Fronius smart meter, we see here the unit positioned right next to the inverter. In our case, this is the feed-in point. In a residential home, of course, this would be the distribution panel at the feed-in point of the house. But there as well, the smart meter is positioned at the very front. Now, I have also one component here. This is the Fronius smart meter positioned. It is a 65 amp free phase in a TS version. There are multiple versions out there, also single phase, that also can be used for this purpose. The communication between the battery and the Fronius smart meter is in every case a Modbus RTU. However, there is one smart meter, a new one called Smart Meter IP, where also a network connection is possible. So via Wi-Fi or LAN, a connection would be ready. All right, now before we go into installation, also a small detail. We of course would go into the cabling first in the installation actually, and therefore we must mount the actual wall mounting plate of the inverter first with 4 to 6 screws, depending on the underground I'm working on. And after we mounted it up on the wall, we take the actual inverter and hang it onto this mounting bracket. And then it looks like this. The next step is to open the front hood with 2 quick locking screws and the hood beneath it. Now, we have now opened the inverter and it would be time to cable the actual unit. So what we can see here when we open the front cover of the inverter is the whole connection area. So we see the DC terminals in this Vago type clamps on the plus side, and on the minus side we see it here. Also written on there we see PV1 and PV2, which stands for MPP tracker 1 and 2. And we also can read battery plus and minus, which is of course for our BYD battery. So that DC side is on the left hand side, the AC side of course on the right. As this is a SIMO Gen24 Plus, we of course have a 5-pole connection with 3 phases here installed. And right next to the AC terminal we also see the PV point. The PV point is built into every Gen24 inverter, and it allows the customer to have a socket like this one here. This is actually our PV point cable, and this socket is only supplied if the grid is gone. So when the grid is gone, the customer can plug in here something to charge the light, also a small electric oven or so with up to 3 kilowatt, which we supply out of the battery if available or from the sun. So this would be the PV point, and it is cabled here right next to it. And it is ready to use for every customer. Now, in the middle of the installation area on the Gen24, we see the communication card, also called Pilot. The Pilot is the brain of the whole system. So this is where we have our Wi-Fi antenna, we have a LAN connection on there. So it's also our connection point to internet and to SolarWeb. And with the free orange plugs, we also have multiple interfaces such as Modbus. So here in the middle orange plug, we have Modbus 0 and Modbus 1. And we could, for example, use Modbus 0 for a cabling to our battery and Modbus 1 for a Modbus cable to the smart meter at the feeding point. Now, as the Modbus RTU connection is a serial connection, we must not forget to also set the 120 ohm resistance if there is an AND component. Now, from here to Modbus 1 connection here, we have no more components in between, and therefore we need to set it on the small dip switch over here and just simply switch the Modbus 1 termination resistor to on, and also on the smart meter we do the same. Same goes for our battery. Switch this small dip switch to on, and on the battery there is also one that we need to activate. I will show you later where it's located. Now, for the cabling, please notice a Cat5 standard Ethernet cable is more than enough. You can use this for a Modbus line. Make sure to use a twisted cable pair between plus and minus, and also the ground connection of course needs to be set. And make sure there is a shielded cable and to ground the shield on one side. Now, to ground the shield on one side, this is possible on a shield connection point on the Pilot itself, which is designed exactly for that, or also on the feed-in point, for example, as you are in the distribution panel anyway. Or also the same would be possible for the connection point on the BYD. Here you can also ground the shielding once. All right, so this is the whole connection area, and it's now time to go into more detail and to look into the battery. Now, regarding the BYD, we have now opened up the side cover of the BYD battery. This is the management unit that sits on top every time. This is the gray box. And here we see all the connection points. Before we go into detail, let me also quickly announce that it's very important to not mix up BYD HVM and HVS modules. You can very simply identify them by 1 or 2 stripes at the side of the battery module. So 2 stripes, it means HVM module, and 1 stripe stands for HVS. Now, we have opened up the 6 screws and are now able to see the connection area of the BYD itself. And of course, very simple to identify, we see a plus and minus pole for the DC connection directly to the battery. We also see a grounding terminal over here and 2 Modbus communication possibilities in order to connect it to the inverter. The first one would be, such as we did, to go for the top one. Like here, it is this connection point where we are able to connect the 4 necessary poles, which is data plus, minus, ground, and a 12 volt steady DC connection. This all 4 pins are able to connect on the Pilot. On the Pilot it's called V+. This means a permanent 12 volt DC supply. Now, all of these 4 pins are necessary for the battery to operate. So this is option number 1. The second option for Modbus would be to use this top RJ45 connection point. And on the side here we can also read it stands RS485. So this also would be possible to use a standard Ethernet cable, plug it in here, and on the other side we simply cut it off, and the according cable pins will be then connected on to the Pilot. Now, while we are over there, we can also see 2 more RJ45 connection points called in and out, which we would use when we have multiple battery towers for one system in use, which is possible. And if so, we must make sure that all the battery towers we use are the same height, so the same amount of modules are being used. And then we can go from the first one, the master, to the second and the third one via in and out. So it's again an interconnection of these modules. Also, what we have is the Ethernet connection. So this would be a possibility for your battery to get internet access. If I want to be able to update the battery once in a while, if I want to be ready for a service case, then internet connection is always a good thing, because if it is in the internet, the support from BYD can directly look into your system and help you possibly a little bit better than if it would be offline. Now, last but not least, we have 3 more dip switches over here, while we here at Fronius mostly use the middle one. So the middle one is called RS485, and it is more or less a 120 ohm resistance dip switch. Is it on the left hand side? It's activated. On the right, it's deactivated. So again, in our scenario, we go from here, from the battery to our inverter, and therefore it's one line, no more components are in between, and we can set this one here to activate. The bottom one is called parallel, and we would only use it if we have multiple battery towers in use. Please make sure to also study the manual of BYD a little bit more in detail if you want to know more about this. All right, so that's it for the connection area of BYD. Now let's get on with the actual commissioning of the inverter. So now that we have got a closer look into the BYD battery and also the connection area of the inverter, it's time to close up the covers again and to start switching on the components and doing the initial commissioning. But now, first of all, let's get this covered up. Next up, we have now the possibility to commission component A, component B, so battery or inverter. It doesn't really matter which one you start with, as long as this DC disconnector is at the off position until the very last step. So very, very important. In our case, for example, we start with the battery, then we go on to the inverter, and at the very, very last step, when we have done both commissionings, we then turn on the DC connector. Very important. So in our case, in order to get this battery up and running, we have a switch on the side of the battery. So we now see the BYD is up and running, the LED is blinking, which also indicates that the access point is open for 4 hours in order for me to finalize the configuration. We can do this with an app on Android and Apple devices. This is what I do here now. You can also go to a BYD support site and download the software in order for you to do it with a laptop, for example. Now, let's go on. We have a tablet over here, and we have also downloaded the B Connect 2.0. Now, the first step that we want to do is to set up a connection via Wi-Fi to BYD underscore and then a serial number. So this is our access point of the BYD battery, and then we open up the B Connect 2.0 app. The first thing that will pop up here is a notification that no internet is available, of course, and therefore we cannot download the latest software, which is okay. This is one thing that you can do before that. Stay in the internet, open the app once and download the latest firmware to this software. And only then afterwards you do the connection to BYD, to the battery, and then you can upload the firmware initially. So in our case, we have done this already, and it's time for us to do the configuration, which is basically step number 2 after the update. So, do you want to configure the system? Yes, I want. This is very easy to do in 3 basic steps. The first one is called time. So date and time, I simply check if those 2 are correct and click on next. Then we select an inverter. of this drop-down menu. Of course, only one real choice here, Fronius. And the last step would be to configure the system. So we need to tell the battery management unit, the gray box on top of every battery tower, which model is selected here or built in. We have an HVM and we have 4 modules connected here. And once again, here on the picture below, we can read 2 stripes means HVM, 1 stripe means HVS. And please do not mix them together. Now, we click on Next and have an overview of our selection here. We select configuration was done accordingly and hit Submit. It also asks us, okay, the SoC of the system is not around 30%. Are you adding a battery module into the system? In my case, no. This is an initial commissioning, so I can press no and then OK. If I was to upgrade the battery with 1 more module, which is possible, or 2 or 3 modules, please make sure that the SoC level has to be around 30%. That's why it was asking, because the new battery module that you get delivered is around 30% as well, and we need the same SoC level in order to get the system back up and running. So very, very important to have the same SoC levels. Now, after the configuration, we are in this home menu. We can read voltages, SoC levels, and this is also a good tool when you have any problems with the BYD battery. This tool can also be used for servicing, not only for configuration. Now, that's this product done. The battery is up and running. Now it's time to go for the inverter. And of course, in order to configure that, we need to switch on AC. Therefore, we see the pilot is supplied with power as well. We have a blinking pattern of the LEDs. And after this one is finished, it's possible for us to open the access point with 1 touch in the middle here on the light sensory button. The right LED starts blinking blue, indicating the access point is open. And therefore, we can reconnect with our tools like the Solar Start app, which I also downloaded and will showcase to you, or you can also use a laptop and a browser. So, our next step would be to go to Solar Start, open this interface and click on Start Installation. We then select which product it is, a Gen24 in our case, and it typically searches automatically for open access points. If this is not working, you can also click on the button below on manual connection, scan a code, a QR code on the side of the inverter, or go to Wi-Fi settings and simply do the same thing as with BYD before. We see Fronius underline and the serial number, which is the open access point. The code in order to enter this is written at the side on the label of the inverter. By the way, the same thing goes for BYD. You also need a password in order to get into here, which is written down in the manual. Now, the first thing that we see is this screen here with 3 major points that we need to fulfill in order to have a full configured product. This is network, product, and SolarWeb. We also can see or read the serial number at the top, so we know with which product we are connected to. Now, if we finished 1 or more of these steps, there appears a green check mark like here, and we know, okay, this step has already been done successfully. In our case, we go to network and fulfill the first topic. And before we can enter here, we need to set a customer password. So I set here one. And it is very important to note that this customer password can also stay at the customer, of course. That's why the name. And with this customer password, there is a possibility for the customer himself to exchange a network, for example. So if he gets a new internet, a new router, he should be able to change this himself, and this can be done with the customer password. Now, the first thing we need to do here under General is to set the previous system name, check time, time zone, and if it's all correct, we click Next. we come to terms and conditions, and it's very important that these are to be agreed. If not, it's not possible to do anything with the SolarWeb monitoring. So very simple. You can select no, but then there is no monitoring for the customer to use. So in our case, we have selected, we have agreed to the transfer of the data, and we hit the next button and come to network settings. So in network, like the name indicates, we select, do we have a LAN connection or a Wi-Fi connection? And on LAN, for example, it would be possible to select if we have an automatic or dynamic IP configuration, or if there is a static IP. So very simple, I can do both here in this setting. The other one, which we also use, is the Wi-Fi connection, and also very simple to use. We select the SSID we want, so the customer's network basically. In our case, it's Energy Lab. We hit it and select the password, the correct, and can now connect to this. If no password is known or the customer has forgotten it, which can happen, you can also activate the WPS feature at the bottom here. But this only works if the router of the customer also has this feature. If so, you hit the WPS feature also on the other end, on the router, and there will be an automatic password transfer from both ends. Now, after this has been done successfully, we can also read at the very bottom, access to SolarWeb, connection verified. Now, this does not mean that the SolarWeb is fully registered and configured. This only means the system, the inverter, is able to go to the internet and get access to SolarWeb. This is all that it means. And with the green writing, connection verified, and a green check mark, we know everything is good. One more point to look out for is if the customer changes the network in the future from Wi-Fi to LAN, it's very important to deactivate the not used one. So if I would to now connect the LAN cable, I need to go to Wi-Fi settings, delete my Wi-Fi here from it, and only select the LAN. All right, so if this is done, we can click Next and have the first topic already successfully done, the network, and we can head on to product. And here it's already written only for trained technicians, and therefore we also need to enter a technician password. And important to know as well, the technician password must not leave you as a technician. It must not go to the customer because sensitive parameters, grid parameters, can be changed here. So we can read here now general data, so PV system name, time zone. We simply check if this is still correct, and then down below we can read country setup. And now it's very, very important to always check on with the grid supplier what settings need to be selected here. Same here for Austria, for example. I need to select the correct country, Austria, and then we have 3 grid codes here in our country, and we, or I as a technician, have to go to the grid supplier and ask, okay, which setting do I have to set here? Very important to always verify. If we have done this, we can hit the next button and come to device configuration. Now, here we add components and also some general data like the PV generator. Now, PV generator, like the name indicates, I set in watt peak what's the size of my PV. So for example, on the first MPP tracker, PV1, I have 5 kilowatt. On the second one, I have none. If I have another one, for example, an east and a west installation, I would have to set here again 5 kilowatt on the second one. So this is what this means, and by deactivating and activating, he also uses PV1 and 2. If the second one is, for example, deactivated, there would be also a feature called PV1 plus PV2 connected in parallel. This is a feature where it is possible to pre-combine multiple string together to one and then go into the inverter. There is also a connection kit for that, positioned right underneath the DC Vago clamps on a DIN rail. And these pre-combined cables come into our DC connection kit, and from this connection kit we have two cables running in parallel into PV1 and PV2. And therefore it's possible to have a bigger generator on the roof and use all the electronics behind it in the inverter and distribute it symmetrically, more or less. So there is not so much stress on one component, but we distribute it onto both MPP trackers. And if I do that, we must not forget to select this small button PV1 plus PV2. Alright, so this is the PV generator. The primary smart meter plays a major role, of course, sitting at the feed-in point, measuring all the feed-in and the consumption, and we simply add it as a component. So if I do this, it pops up primary smart meter, and I have the ability to select between a Modbus RTU and a Modbus TCP smart meter. And as we have heard in the beginning, it is a difference if this smart meter, for example, is connected. This is only a Modbus RTU connection, or if the new Fronius smart meter IP is used, which has a Modbus TCP possibility via LAN or Wi-Fi. So this is the way I choose here. Now, then I also select the application. In my case, it's a grid connection point. And a grid connection point in a primary smart meter always must have the Modbus address 1. This is also ex-factory on the smart meter itself. If I now want to add a secondary smart meter, I simply click Add Component, Power Meter, and there pops up a window with Secondary Smart Meter, as there is no way to add a second primary one. Now, for a second smart meter, I can also select between smart meter RTU or TCP connection. I select, is it a production meter or a consumption meter? Let's say, for example, I want to measure exactly what my heat pump uses. I go to consumption meter and position the smart meter in the consumption path of this device, of the heat pump. I then select category and select heat pump, and I would be also to give a name for this. And we also read down below that Modbus address 2 is selected. And this must also be changed at the display of the Fronius smart meter. So there is a code 2633, which is also written down in the manual. And then you need to go to address and change this from 1 to 2. So in our case, we have no secondary smart meter. That's why I cancel this one here. Next up, we see a BYD battery. So yes, of course, we add a component, and there we have the possibility to add the BYD battery. Also with LG, it would work the same. So you have a drop-down menu and two compatible batteries will pop up, BYD Battery Premium or the LG Reso Flex battery. And if we select it, we have a few possibilities. The first one would be the SoC limit, which I suggest you to leave on automatic. So from 5 to 100%, this is minimum and maximum SoC level. Don't change this if necessary. This is, by the way, not the reserve capacity. This is something totally different. For a full backup mode, for example, I could reserve some battery capacity for the emergency situation. This is not it. We come to this point later on. So two more options are available here. The first one being called Allow Battery Charging from Other Generators in the Home Network, which is very nice to have if I have, for example, a second Fronius smart meter or a wind turbine or a small hydroelectric power plant. Because I simply select which AC power in watt will arrive here in my grid, let's say 5 kilowatt, and this will be then used by the Gen24 in order to charge the battery also from this end. And the second button is called Allow Battery Charging from Public Grid, which is to be set as soon as we want to do battery management settings, which we can do later on. So a battery management setting would be, for example, if I want certain time zones from midnight to 6 a.m. in the morning, I want to limit my discharging of the battery to 1 kilowatt or so. This can be done in the battery management settings. And as soon as I hit something in there, we need to select this button. So in my case, I don't have anything selected. I can now conclude this and go to next. The next thing is functions and IOs. So the bottom one first, this is called load management, and we simply, if we want to use it, need to activate it with this toggle. And we are now able to tell the inverter on which pin we have something connected. So let's say load management number 1 is connected to pin number 1. This means that I have now the possibility to select certain thresholds, which we can do later on, thresholds where this pin is being activated and a certain load is being activated or drops. So for example, my pool pump can be connected to pin number 1 and the threshold is 1 kilowatt feed in, and then it will turn on the pool pump. So we have 4 of these pins available. This is the biggest orange plug on the pilot where we have these connected. And yeah, so this would be the first step, to tell the inverter where the cable is connected to. All right, in our case we don't have this, but what we do have is a so-called PV point. We have heard it already and we have seen it already. The PV point is a backup option that we can select. Therefore we need to toggle this button at the top. Then we need to select the backup power mode. Standard is off and we need to go to PV point. Full backup would be also possible. And then we need to select, okay, what's the reserve capacity? And here we would be able to select, for example, from the standard 7%, we want to increase it to 30%, meaning that 30% of the battery will be reserved for emergency situations. We do not touch it in grid parallel mode. Only when there is a grid outage, we also use the last 30%. This is where we set the reserve capacity. All right, we have done this now and click Next, which leads us to the final step, the export limitation. This is standard set to off, and we can now click, for example, on Limit the entire system. Now here I would have to enter the total DC power of my system. In my case, for example, I say it's the 10 kilowatt peak. If I have a second inverter with 5 kilowatt, I would have to enter here 15 kilowatt peak. And then the next step is to select the export limit control, so the soft limit. Very important, do not use the hard limit. It's not necessary here in Europe. It's only a control necessary in Australia. So the soft limit means that we can select, for example, okay, my grid operator does not allow me to feed in more than 4 kilowatts. So the inverter will search for any self-consumption that we might have, and only the surplus will be sent into the grid. And if we would exceed 4 kilowatt, he will regulate down the output power. This is how it would work. All right, in my case, I do not have any export limitation to set. Click to off and finish. Now the second step is done, network and product. And now it's time for the last step with SolarWeb. Now as soon as we hit the third button called SolarWeb, we jump to SolarWeb. That's only possible when we go to the internet connection again. So we leave the Wi-Fi access point of the inverter. And then we have 2 options here: to start the SolarWeb setup or to invite the PV system owner. And my recommendation would be always to go for Start SolarWeb Setup. Then you fill out the whole slide here. So PV system name, that's training from before. The serial number will be copied automatically. The V code is written next to the serial number on the nameplate of the inverter. We fill out country, state, zip code, everything, and then we go to finish. And after we hit that button, we will automatically attach this system to our SolarWeb account of us, technician, as installer. And after that, we see it in our overview. We are able to do a software update if necessary. And what we must not forget is to go to SolarWeb, to this system, go to settings and do a system owner change. And this is where we then invite the customer with the email address to get his own system as system owner. And we have the possibility to stay active in here to see everything as a technician. So this would be the step how to do the SolarWeb settings. All right, so this is it for installation and commissioning of such a system. The system is now up and running. If you need more information, you can find it in the video description of this video.